Hi everyone, the winning inductor has been selected for the boost converter, and it is the 4.7 microhenry inductor. It was narrowed down to the top three being 1, 2.2, and 4.7, which was the range mentioned in the data sheet, so that's great news. 4.7 was selected based off of its slightly lower startup voltage and stable output as seen on the monitor, not the waveform, so further analysis on that aspect is needed. During testing, one of the important things that popped up was the capacitor. So when the capacitance is 0, when it's not populated, then the servo motors will not turn. However, the rest of the system will operate. So I'll go ahead and demonstrate that now because it's pretty interesting to see. Alright, power supply off, safety goggles on and soldering iron on, and ventilation on. Iron off, goggles off. Alright, now, sorry, we have removed the capacitor from right there. So we'll go ahead and power up the system again. So it's outputting 5 volts. However, the servo motors do not move. The rest of the system is powered, the neopixels are illuminated, and the microcontroller is running. So what's interesting about this is that we've learned that the capacitor is necessary for this design to operate, and that now brings up another design requirement or constraint, which is the height of the capacitor. Because on the plane that these boards will be on, there will also be a tactile button. We're limited in the height of the capacitor based off of the maximum height of the plunger of that tactile button. So for example, this one would likely be too tall, whereas this one also is 1000 microfarads, whereas the 680 microfarads one will likely be okay depending on the height of the plunger of the tactile buttons that can be sourced. It's also possible that we may find even larger capacitance with the same height footprint. So this will be interesting to do some part searching for in order to find the component that meets those requirements. The 300 millivolt problem has been resolved. This was due to the diode that was on the output of the boost converter only on version 1.0 of Boostlet. On version 1.1, this was removed because of the selection circuit. So I can show a simulation of the selection circuit to show there won't be any voltage drop. So let's see here. enable this. So that output is 5 volts. That output is 4 volts. So no more voltage drop. We'll see what it is in reality. This is just a simulation. Until next time, the research will continue with these low-powered embedded robots.